Hello friends. So this problem is about a sleeve sliding on a circular rotating rod. So problem says a sleeve of mass M can freely slide along a smooth rod bent in the shape of a half circle of radius r. The system is set in rotation with a constant angular velocity omega about the vertical axis as shown in the figure. And we have to find the angle theta for the steady position of the sleeve. So here we have a sleeve and a semicircular rod. So this is the semicircular rod and this is the sleeve S. And this semicircular rod is rotating and the angular velocity about which this is rotating is given. This is omega and this is the axis along which this is rotating, vertical axis. Now at certain point of time, this is here is in a steady state situation, radius is given and theta is given. That is it makes an angle theta with the vertical. So now if we analyze this situation, what will happen? This sleeve is basically rotating in a circle. So if you can think little bit, then you will find that this sleeve is rotating in a circle. So what are the things that is given in this problem? So we have been given mass of the sleeve, radius along which this is rotating or the other radius of this semicircular path, and this is also given. So friction is 0, there is no friction, mu is equals to 0, omega is constant, so it's moving with a constant velocity omega. And we have to find angle theta. So let me first show the forces. What are the forces that is acting? So mg is acting in the downward direction and this sleeve will apply a normal reaction in this direction. So this is along the radial direction. So this is the normal reaction. This is the normal reaction. Now this normal reaction will have two components. One component along this direction. So normal reaction will have one component in this direction and another component in this direction. This angle is theta. So this angle will also be theta. So this will be n cos theta. And this side we will have n sin theta. N sin theta. And what will this radius? So this radius along which this is rotating from here to here, what will be the length? This length is r. So this length is r, that is given. So this length is r. So what will be this length? This length will be simply r sin theta. So this length here we have is r sin theta. So let me write it here. So this is r sin theta. Now you know the component of normal reaction. You also know that this is moving in a circle of radius r sin theta. Now pause this video and solve the problem yourself. Okay, so let us solve this problem. So what we can do is, since this is in equilibrium, this is in the steady state, we can equate the forces. First force in the vertical direction, that is n cos theta is equals to mg, because there is no acceleration in the vertical direction. And another force about this circle. So force towards the center, that is radial force, is equals to mass times acceleration, that is the radial acceleration. Radial acceleration is nothing but v square by r, and we can also write m omega square r. So m omega square r, where r is the radius along which this is moving. So m omega square r. In the radial direction we have only one force, that is n sin theta, and this is equals to m omega square, and r is how much? R is basically r sin theta. So this is my second equation. So if you divide these two equations, you can basically, so in this case sin theta gets cancelled out. So you have simply n is equals to m omega square r. Now if you plug this value in equation 1, so you will have m omega square r cos theta is equals to mg. So m cancels out, so we will have cos theta is equals to g by omega square r. So this means theta is equals to cos inverse g by omega square r. Now this is true only if omega square by r is greater than g, because this term has to be less than 1, because this is a cos inverse. Now if you have another situation, that is g is greater than omega square by r, or you can say omega square by r is less than g, in that case this term will be 1, greater than 1, and there will be no solution for theta. In that case what will happen? This sleeve will come to the minimum position, and then from here it will make a circle. So in this case theta is equals to 0 degree, you can say. Now can you tell me, so this is the question for you, what will happen to theta if I increase omega? So think physically, without any mathematics. If you think, what will happen if I increase omega? So this means now this is moving with a fast rate. Whether this sleeve will go up or this sleeve will go down, or it will remain at the same position. This means a new equilibrium will be achieved, or will it remain at the same equilibrium. So let us discuss this in the comment box, and I will see you in the next video. I hope you enjoyed this video, and if you enjoy, please share with your friends and subscribe to my channel. Thank you.